Here on the right, you can see Riverdi 7-inch EVE4 display. Next to it, you can see Riverdi STM32 Evaluation Board, which works pretty well with ST-Link. Here is V3 version, it also works with older V2 version. From cables, you will need two micro USBs. One to connect your ST-Link to your PC, and the other one to power up STM32 Evaluation Board by Riverdi. Here I have AC/DC adapter. To connect your STM32 board with display, you will need RiBUS cable. This is 20 pins flat cable. Now I will show you how everything is connected. Starting from the top, you have ST-Link that is connected to your PC by micro USB cable and connected to evaluation board by female-to-female cables. Riverdi evaluation board is supplied by micro USB connector and connected to your display using RiBUS cable. You have RiBUS connectors on both devices, obviously, and the cable itself is 20-pin flat cable. As you can see, it's pretty easy to bend, so pretty convenient to use. So to begin with, you need to get the code from GitHub, and to do that, all you have to do is go to Riverdi GitHub, find Riverdi EVE4 demo project, press green code button, and either download the zip file and unzip it in the convenient directory, or copy the link, open the proper directory. I already have it there, called Riverdi EVE. Open the command line here, and here you should see, you just put git clone and clone the project. Okay, when the code is there, you can see it's downloaded, Riverdi EVE4 demo. All you have to do is open STMcube IDE. And when you're there, you just import the code. To open the project in STMcube, we can either press here on the Create New Makefile project in the Project Explorer window, or we can press the File, New, and here is the same option, Makefile project with existing code. After choosing that, we have to find our code. I already have it open. And here, the important part is to select the proper toolchain. For us, it has to be MCU ARM GCC. Press Finish, and then you should see your project on the left. After opening the project, the main thing is to choose and create the proper makefile. Here on the left, I choose makefile STM32 Evaluation because that's the platform I'm using right now with Riverdi Evaluation Board. As you can see when I open this, everything is in gray, so STMcube doesn't know its makefile. All we have to do is choose the proper one for us and rename it to just makefile. After doing that, you can see the icon changed, and after opening, you can see it's also interpreted by Cube as a makefile. Now, all we have to do is choose the proper parameters of our project. Here I have EVE4, I keep it as it is. Also the same for EVE4 external oscillator. And I also can keep IPS 7-inch as that's the one I'm using. But for you, if you have bigger or smaller screen, there is no problem. All you have to do is comment it and uncomment the other one, and then save the file. For me, I will keep 7-inch. When the makefile is ready, you can open Riverdi demo.c. In this file, we have our main function, but also we have all the other functions to use later on the screen. First thing, in the main function, we create a pointer to the host that we will use later for our GPU engine. At first, we need to initialize our board. Here in AppCommon init, we have GPU HAL init, which goes to platform init. Here you see we have 4 platforms to choose, same as with makefiles. Choosing STM32 Evaluation platform.c, you can see it only initializes the clocks of the board. As you can see, after the clocks are initialized, we can go back. Next function is GPU hull open. GPU hull open assigns the proper GPIO pins to the SPI's chip select, power down and interrupt. Also sets the chip select and power down pins high to not turn the screen on yet. Next function is GPU hull power cycle. This function turns on or turns off the EVE display. After the EVE display is on, now we can talk to EVE. As you can see, regarding on which EVE you're using, the proper clock frequency is written to the register. Then GPU host command sets GPU active mode. After setting GPU to active mode, now we have to read the register ID. By doing so, we are verifying if our connection with EVE and everything that we set so far is proper. If we have wrong frequency or anything else is set up not the proper way, we will not read the register ID properly. After reading the ID, we have to set the proper values to the EVE4. For EVE4 only, we also set the PWM frequency and duty cycles. And later we set the proper registers with all the data that is predefined for each EVE, each size of the display, and each type of the display. After all of this, we can get back to riverdidemo.c and start working with our function. Now we can get back to our function change color on touch. When you open it, at the very top you can see pole interval milliseconds and the array of colors. Here I have orange, green, blue, black and white. At the very beginning we call draw solid background with the colors of our array with the index that is equal to 0. To see what is there, I can explain it to you right now how display list works. Display list is a list of drawing instruction like draw line or draw bitmap stored in EVE's memory. Here we have clear color RGB to set the background color. The EVE GPU processes this list every frame to render the display output. The microcontroller builds or updates the display list by writing commands to the EVE's command buffer, which we can see exactly here. When the list is complete, the MCU signals EVE to swap and show the new display list, which is GPU display list swap command. Now we can get back to our function, and you can see we have a while loop that checks if our screen is touched. Whenever we release the touch, we draw the solid background with an index +1 that obviously we check if it doesn't extend our list too much. After that, we get a delay for 5 milliseconds to give it enough time to draw it. Now we can start with running the code. Please see this is the device that is plugged to the power supply. You can see the backlight is on. When I unplug it, you can see it's a bit darker on the screen. I plug it back in so we can use the screen and our EVE. First thing, we build it. You can see new files are appearing on the left. Now we have to debug it. There is no previous launch, obviously, if we debug it for the first time. But if you press it and focus on the code and then press it, you should have the edit launch configuration properties. And without changing anything, you can press OK. It automatically should be fine. And then the code should run. Okay, it got to reset handler just to reset the port and the software. And now we can press resume. You can see it's now a bit brighter, and when I press the screen, it changes the color. And to show you how it works, you can follow me here. Yeah, I put a breakpoint in the line draw solid background function, and when I enter, you can see we change the background, we clear every buffer,
We close the display list, flush the buffer, and now after we go through the swap, it should be changed when I press the button right below. And you can see the screen changes and it exits the function. So when you remove the breakpoint, it works properly, and as you can see, it's the moment when I release the finger, as our code is intended to do.